The recording, please,
Yeah,
Brian.
yeah, I have started recording.
Thank you.
So Salim bhai, just a page before I think, is there a slide for types of databases and stuff, or just one?
So, in my previous slide, actually, I did show you the different kinds of databases. If you
Hmm.
go here, so you have something called on a major front all throughout the world, the application development framework actually the SDLC, if you consider actually all the applications in the world usually use two kinds of majorly defined databases. One is SQL databases, SQL, structured query language databases, and one is called
Hmm.
NoSQL databases. Now SQL databases are more of relationship database management system. So we discussed that in our previous slide. Like we had a relationship established between the database structures or the attributes within a data. So here in NoSQL, you don't have a relationship established. It is more of a kind of created as documents, actually, simple column stores. These are all documents in a database, actually, small
Hmm.
documents containing data, actually.
Hmm.
So those do not contain any relationship, but they can be very fast, and it contain. I mean, this is what very fast accessing. If we go for financial institution, if you go for financial institution, banking segment, banks, and major of the e-commerce sites, all those things they use the RDBMS, Relationship Database Management System. And if you consider more of online applications like Facebook, Twitter, which have very fast processing of data, there they use the NoSQL database actually. Again, further, if you want to store documents and other things, there are more kind of databases, which are again NoSQL databases. Those are called document databases. So these are document stores and those kind of stuff. You can have document databases. Every company may be using SharePoint and all, right? So you know what SharePoint is,
Yeah, yeah. So
right?
the reason why I was asking was I googled when you were talking about the databases or types of databases, and in the Google it shows like a list of databases, and then it is not clear. It says three types of databases: hierarchical, network, and then four types, different types. So I was like, what exactly are types of databases actually?
Okay, so from your point of view,
Sorry to interrupt, brother Salim. Abdullah and other brothers are waiting to be added.
okay. So basically, you need to understand from a majority point of view. See, any what is a database is nothing but any kind of a store where you store in your data is called as a database. You can create your own file server as a database actually, but there is something called a structured database or a unstructured. So if we consider something as structured database, these are the available provisions available right now available provisions that you can have your database clearly structured. So
Assalamu alaikum.
one is
Alaikum
called a
salam.
relationship database management system, one is called as a non-relationship database management system. So under relationship database management system, you have multiple different kind of databases, starting from if you just google around, so different kind of RD, like, so you find huge amount of, see, MySQL, SQLite, MariaDB, SQL Server, Oracle, Firebird. So you have n number of database servers, DB2, IBM DB2. These are pretty large actually. See, if you should,
Mhm, mhm,
the Oracle is one of the largest in the world. SQL Server, IBM DB2. These are the three larger databases predominantly used in large enterprise applications. However, for small e-commerce applications and small time, not very large enterprise applications,
uh-huh.
we use Postgres. Then they use MySQL, MariaDB. So MySQL itself was MariaDB earlier. They broke last time I told you about it actually.
Okay.
So there are
So
huge.
in the bottom, if you see in the Google list, people also ask, they have like, what are the 3 types of databases right there? Yeah. No, down below. Yeah. Third one. Yeah.
Yeah.
So I was also looking this actually. So is it more related off to the code, and then with different types of functionalities, you have different databases and stuff like that?
So again, how they have defined this, you need to let me check that actually. Give me just 1 minute. So what do they mean by network database and hierarchical database?
Mhm.
Let me check that. So it's just a representation. So it is just a representation, guys. So don't get confused here. So it is just a representation. So the database kind itself is only 2 kinds. It is one is RDBMS and NoSQL database and RDBMS actually. So this is a kind of a representation. There is so you have relation. This is the relationship database. Now here you have they have further divided into object-oriented paradigm and you have something called network database. This is interesting actually. So I myself had not seen this kind of representation actually.
Mhm.
So what do they mean by hierarchical database here?
So I think it's divided into various functionalities.
So it's just see one-to-one many. These are all RDBMS concept. This model supports one-to-one, one-to-many, and many-to-one relationship. This is a clear. This is a relationship database management system. It's just a representation how they have represented it actually.
Okay.
So there's no
And
difference. So if you don't get confused on this one, so this is see if I go back here. So you have a university here. The university has a relationship with departments and administration. So it has
right.
two things, two major relationships. One is it has a department
Mhm.
and it has an administration. If you consider the relationship database management system as a whole, so
Mhm.
you create a major table called a university or a database named university. You create tables department and you can create a table called administration and you create a relationship between these two things. So every department has an administration and
Mhm.
every department has a number of students, it has facility faculties and it has the resources for that department. If you see an engineering department, you have engineering students, the engineering faculty and the resources for the engineering like the books, the labs and other things. If you see a zoology department, you have students for zoology, students of the faculty for the zoology department and the resources like the labs and other things for that. So you create those tables. So again, this entire whole thing is a relationship database management system. There is nothing called hierarchical. So it's misnomer or it is kind of
Ho-
wrongly represented
How
here.
how about the object-oriented
So even
databases?
here, if you see here, those familiar with object oriented is a kind of a is a concept where you have everything is related, treated as an object actually. So it's a programming concept wherein you create an object and you inherit the properties of that object into a child object. So you
Right.
have a parent. So parent has some attributes like you have a class, then you have a subclass like that actually.
Mhm.
So constructor. So if you are familiar with the object,
Yeah. Uh-huh.
right?
Uh-huh.
So
Uh-huh.
everything is treated as object. Here also you have a person. So the
Mhm.
person has some attributes. He is whether he can be a student or he can be a professor,
Mhm.
right? And he has an address. So again, there is a relationship here established. So even this is is a relationship database. They've just given the name as it's a representational name. There's nothing called object-oriented database. So if I
Oh,
Google this, there's nothing. Only they've represented it. It will again point me to
Okay. So how about the databases which are not related? So that do they come in non-relational databases? Like
See,
if
for
I have
example,
simple
multimedia is
name,
it's a relational database on a higher database management system in which information represented. So it is a relationship database management system. So
okay, I
it is the
see.
way you are representing and using it,
Okay.
right?
So
So you're
basically, maybe we have two types of databases, relation databases and non-relational databases.
exactly.
Is
So
that right?
those are the only two kinds of databases. When you see
Uh,
very
okay,
broader perspective.
okay. So with the reference to the non-relational databases, like how do they look? Is it just like a person, a class with a person, a name, like person class with an attributes? That's it.
Yeah.
No relation,
So,
nothing.
so in my last class, I hope you remember, I showed you how it is actually. So I can show you once again. So I have a database server running. I showed you a live example.
Mhm.
Hold on a minute. I need to start my server.
Or you can make that decision if you want.
Hey, Abdullah, your voice is breaking.
Yeah, probably. If you want to record the session.
Yeah, we are recording the session. So this is a relationship database management server that I have created.
Oh yeah, we have seen that actually. Yeah.
Exactly. So if I take one of the database, like for example, I take this database. This is the name of the database. These are the attribute, or these are the different tables. Like you have the student name, student ID, same thing actually. So I have something called members, and if I go here in the members, so I have the member name, member email address, telephone number, password, when was the PK, when was he created, when was he this one. Now every member has associated with a company. So this contains what is the company name, what is the company contact person. So all these things. So it's the same way like the here what you see.
Mhm.
So every person, he has an address. Every person, he belongs to a organization, company. Every
Right.
person has a, he is a member of an event. So that kind of a relationship. So it is. This is only a representation, but overall, if I see the, if I go back to the database and get into the designer, actually,
Uh-huh. So how about anything with this non-relational database? Do you have any examples, Salim bhai?
I do have an example. I have created. Databases
Like, is it? I just want
MongoDB.
to get clarification between, like how. I'm just curious how the non-relation would be.
See, there is. So if I check on the member, I see there is a relationship established here. So every member, it has a relationship with members, the member
Mhm, mhm.
ID, member contact list,
Right, right,
his address, see
right,
company address. There's a relationship established here.
right, right,
Right?
right.
It's just it's
How
a
everything is
representational
related.
way how you
Yeah.
want to do it. But there is actually nothing called OOPS, object-oriented database. It's only a
Okay, okay,
representational way, right?
okay, okay.
So NoSQL database,
Makes
I have it,
sense.
but it will take a little while. So what you can do is you can create a MongoDB, but considering that we already have,
Uh-huh,
um, we want to practice more on AWS. You,
uh-huh.
we as a lab session, we can log into AWS and create a DynamoDB. DynamoDB is offering from AWS actually. So let's
Okay,
focus more on that. It is a NoSQL kind of a database. It's a columnar database.
okay.
Now, if you see this one, this is a row database. So you have a complete all sets of rows here. So if you see
Right.
NoSQL database, it would be like this here. You see here, this is how it would be. So a single table, again in a NoSQL database, you
Mhm.
have something called key value store, column store, graph store, document store, different kinds of. These are 4 different basic kinds, but there are many more that have come up now actually. So if you consider these 4 different ways actually, so here you have all the attributes of a single person stored in one record actually. So in one row you find all. Here, what I have in a relationship, what I have done is I have the member ID here, then I have the address in something, his company name in a different segment, and I have different relationship. Then I have created a relationship between these tables.
Okay.
Okay. Now there is a member, so there is a member ID. He belongs to a different company. Now I create a relationship between the member and this one. Here is a member and he belongs to a different company. Then again, I've created he belongs to a group, right? So I've created kind of a relationship here, putting data in different groups. When I want to pull data from one particular person, then I need to join. There is something called joining. So that is what we call as one-to-one map and many-to-one map, all those things. So if you go search for RDBMS database joins, so these are different kinds of joins actually.
I see. Okay.
Hold on, oops. So if I go here, that would be, so there's something called inner join, outer join, left join, and right join. So these are some of the joins. I join the tables to fetch the data.
I
If
see.
we go here, so here, so you have the phone, you have the person ID here. Then you have a person number here. So you want to get a number of that person one. So I join these these 2 tables and fetch this data. For example, I want a name of the person whose person ID, whose employee ID is 3. So what I do is I create a query wherein I join these 3 tables. So this table does not have the person ID. You see this?
Yeah, yeah.
So this has the person ID, this has the phone number, and this has the message. So I want a person's first name, last name, and a message,
Okay.
and the phone number of the person ID 3. So what I do is select person ID, details of person ID, where person ID is 3, join it with the database 1, the table 1, join it with table 2. So I create a join here. So I think this is a better representation. So I
see.
join
Okay.
multiple tables to get my data. Now here, what happens here is there will be hundreds of tables containing enormous amount of data. So when I create a join, the joins can be bigger and bigger. It goes, you can write procedures. Procedures are a group of SQL statements actually. It's a programmatic way of building your SQL statements. Okay.
Okay.
So when you build that, so there is definitely a kind of delay in fetching the data because you are trying to fetch data from one and trying to link it to other tables. So it will create a kind of a delay. Now, in kind of fast processing applications, single page applications like Twitter, Facebook, and all, right, where you need to immediately chat functionality. When you enter a chat, right? So immediately the chat has to reach to the other person, and it also has to, a response has to come back in a fraction of a second. So this kind of relationship will not hold good. So that is the reason why they store everything is as this one. And also your chat thing has to be saved, right? So it has to be saved fast. Right. So this is more tedious process. It involves more of complication. You store, like if I update my record for 3. So I need to update here, I need to update here, I need to update my department, all the places I need to update. So if you go here again, so I need to update all the places actually.
Right.
So that update itself will take a lot of time. So here I just update my document. So it will create a new document and I create one primary key, and if that primary key matches, it will delete the old document and recreate a new document. And all attributes are in single row. Everything related to me is single row. There's no relationship that I can establish here. So this is a very fast kind of, much faster kind of.
Okay.
We are timing out in 10 minutes. We'll continue back again.
Oh, okay. S-
Okay.
So
So
Salim bhai, with the relational, these are non-relational databases.
these are
Everything is
non-relational databases.
okay. Relational is basically you have all the hierarchy. I mean, the connections basically with
They
links
you
and
have the
stuff.
connections like
Right, right.
this is a kind of a and or gates actually. So if you have studied electronics a little bit, so you know about and gate, or gate,
Mhm.
right? And or
Union, intersection.
or so intersection. So those kind of is only a
Right, right, right.
union kind of a this one.
Mhm. Yeah, yeah, yeah. That
So
makes
joins
sense.
play a very important role. For you to work on a SQL database as a SQL developer, you need to understand how these joins work. These are little sometimes confusing. You need a little bit of practice, but you will be able to write good queries using the joins actually.
Okay. That makes sense.
So here I think he has explained a little bit better. You have a table 1 and table 2. An outer join joins these rows and these rows as well. So union joins 1, 2, 1, 2, 3, 4. So it brings all the components of here and all the components of here. So inner joins is the common components. See, here you have one, here you have one. So only the inner components. So that is inner join. So left join is you have whatever is in the left in the table 1 that you are joining, and whatever matches in table 2 that it. So table 2 only one row is joining, so it only represent one. So it adds all the rows of table 1 and only the row that has existence in table 1 you join here. So cross join again, you join this fetches lot. This is of mix match, one with one, one with three, so like that actually. So it is a kind of a what you call that keylogger kind of generator, right? So
Right, right.
so that kind of, that's called cross join actually. So most important of these are inner join, the outer join. These are the two most important one. However, these are very much used when you are creating, generating audit reports and other thing. So there you use it. But this is the most important one. The inner join is the most important one. So this is a completely whole study. So you may want to investigate and read in further if you want to understand more. From our
Sounds good.
AWS perspective, we just need to understand what is a relationship database and what is a no relationship database and where it is used.
Okay.
Very important, very important. You should know where it is used. They will definitely give you a scenario and ask you what kind of database should be using. Like, for example, they'll give you a chat application. I'm creating a chat application. I need my data to be processed fast. I'm least concerned about any relationship. So they will give you two options. Should I use Oracle database? Usually they will prefer, should I use Amazon Aurora database or should I use DynamoDB database? There'll be options like Amazon Aurora, DocumentDB, then you will have DynamoDB and other. So you need to choose DynamoDB if it is a single page application and which does not require a relationship.
I see.
It's a very tricky thing, but you need to know mainly what are these two kind of databases and where they are used. Okay,
So
for
basically the storage, the DB instance talks about the storage here, right?
yeah. So when you buy, AWS gives you, as I mentioned to you. So let's log into the database AWS account quickly. let's log into AWS account. So my daughter was using this. She has changed the. So others, are you getting me?
Yes.
We're going a little deeper here to try to understand based on you guys' questions. So feel free to ask questions, but ignore if you already know about the concepts. So if I go to my services here, so these are the available database services that AWS provides. So developer, robotics, database analytics, management and governance, blockchain, customer storage. Yeah. So you have something called RDS, you have something called DynamoDB. These are the main two actual databases. They brought in something as Neptune, DocumentDB, Keyspace, and these are some new database. This was not there. So I think they released the Keyspace and timestamp. This was not there. So this they released last year actually. So even I have not got into this one. But from the exam point of view, only these two are there, the major databases. We can check in what these are. Neptune. Neptune I have not worked into. Elastic Cache is more of caching database actually. For example, whatever data that you are pulling out from the NoSQL databases, like we studied about the CloudFront. Did we not? So you have, yeah. So you have something you are accessing from here, right? You are accessing from here. So here you have your database, right? So here you have your cloud where you have your internet. From here you are accessing. So your data gets cached into the cloud, right? So now the caching also is in a kind of a format actually. So you can use a couple of services in Elastic Cache. The Elastic Cache is a service from AWS wherein you cache your data in a formatted structure. So there are two services in Elastic Cache. One is called Memcached and Redis. These are open source. So these are open source Elastic Cache services, the open sources which Elastic Cache uses to store in your data in a structured format so that it can be easily retrieved actually. But again, your actual data is actually stored in your database. Here it is a kind of a provision. It provisions you for a caching service in a structured way. So these are separate concepts altogether. So you just need to understand from the exam point of view what Elastic Cache is and what is Memcached and Redis. So if you go here, you will find actually. So Elastic Cache provides Redis and Memcached. Redis is a separate company. Okay. Now Elastic Cache is a service which uses this open source Redis and Memcached. There are two different kinds actually. So you may want to read a little bit before you go into the exam. You don't have to need to understand more in deep about this one. It's only a case scenario where it is coming into use. When we see that these are not actual databases, these are only caching, structured caches actually, which will help you in fetching your data in a structured and a more efficient way, which will reduce your latency as well. So this is called as a in-memory data stores. In-memory means it caches actually, built for the cloud actually. Redis and Memcached. So there's a slight difference between those two usages. So AWS provides both Memcache and Redis as well. Confusing?